Okay, so in this video, we tackle about the topic of calculus. So what is calculus? Calculus is a branch of mathematics involving or leading to calculations dealing with continuously varying functions. So when we say continuously varying functions, okay, so it is applied the real world context or phenomenon situations. So mostly in engineering, different kinds of field subject, okay, so or related subject, which is involving the engineering mathematics. Okay, so for example, in electrical engineering, calculus may be applied in electric, and mechanical engineering, calculus applied in fluid dynamics. Okay, so in civil engineering, calculus applied in structural analysis. Okay, so in industrial engineering, calculus are applied in uh, business. Okay, or in management, okay, that involving engineering problem or engineering mathematics problems, okay, so that needs problems or solutions. Okay, so the term calculus was derived from a Latin word calx, so which means stone, and from a Greek word chalice, which means limestone. So in 1684, a German mathematician and philosopher Gottfried Wilhelm von Leibniz published his work or published his early work on calculus, while an English astronomer, physicist, and mathematician Isaac Newton made an early study on the subject in 1685, but did not publish his work until 1704. So these two mathematicians are now considered as the founders of today's calculus. Okay, so calculus is a subject that falls into two parts or divided into two parts, which is differential calculus, or another term is differentiations. Another is integral calculus or integration. Okay, so we define first differentiations, or we focus also the differential calculus. So what is differentiations? So is used in calculation involving velocity and acceleration, rate of change, and maximum and minimum values of curves. So differential calculus is a branch of mathematics which deals with derivatives and limits. So that is the meaning of differential calculus. Okay, so no other than that is derivatives and limits. Contains with derivatives and limits. So what is functional notation? So for example, for this quadratic equation or for this problem given, okay, so y is equals to x squared plus 2x plus 1. Okay, so y is equals to f of x. It means a function of x. So f of x is equals to x squared plus 2x plus 1. So that is called a functional notation. Okay, so it is said that y is equals to f of x, okay, and then we transpose into the this equation into uh, f of x, okay, so this term is a functional notation. Okay, so for example, with this, no, f of x is equals to 0, so we can now read as or f a function of 0. Then if x is equals to 2, then f of 2. If x is equals to negative 4, then f of negative 4. Or f a function of negative 4. Or f a function of negative 2. Or f a function of 0. Okay, so We solve that, no? Okay? So when we say f is equal to 0, so therefore we substitute from this problem example given, no? Which is f of x is equals to x squared plus 2x plus 1. So we substitute the value of x is 0. So 0 squared plus 2 times 0, that is automatic 0, no? So therefore, the result of the answer is f of 0 is equivalent to 1. So that is the answer. The next, if x is equals to 2, then substitute f of 2 is equals to 2 squared plus 2 times 2 plus 1. So the answer or the equivalent of f of 2 is equals to 9. So that is the answer. Then if x is equals to negative 4, or f a function of negative 4, so substitute if of negative 4 is equals to f or of 4, or the quantity of negative 4 squared plus 2 times negative 4 plus 1. Okay, so negative 4, so take note that positive negative times negative, that is positive, no? Okay, so that this is a 16, then 2 times negative 4, that is negative 8. So 16 minus 8, that is 8. Then positive 8, take note, then plus 1. So therefore the answer is f of 4 or sorry, f of negative 4 is equivalent to 9. So another is, what is the gradient of a curve? So for example, we have the graph, no? It is levelized. So here, this is the y-axis, but we change into a function notation, which is f of x. So we have the origin and then x. So we assume here a curve, okay, then point P. So the straight line, okay. So the straight line is tangent to the curve, okay. So if a tangent is drawn at a point P on a curve, then the gradient of this tangent is said to be the gradient of the curve at P. So the gradient of the curve at P is equals to the gradient of the tangent P and Q. Okay, so take note of that. So from this graph, okay, we level. Okay, so we put here from the distance, which is f of x sub 1. Then another side is f of x sub 2. Okay, so we indicate here, we make a triangle here. Okay, so from this point, we indicate the point E, point B, then C, D, then E. Also, we indicate here from the distance from origin to here, which is x sub 1. Then another is x sub 2. Okay. Then next. So therefore, the gradient of the curve EB is equals to BC over EC. Okay? Is equals to BD minus CD over ED. Okay? So, or else, f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. Okay, so that is we find a gradient of a curve. Okay. So next, for example, the curve of y is equals to x squared. Okay, so we have the graph. So the important having of this is to graph. Okay, to understand easily, no. So we have a graph, no. This example graph. Okay. So find gradient curve of EB, BC, and AC. Okay. So here it is EB, then BC, then AC. Okay, so ingredient curve of AB, so we use this formula. Okay? F of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. So the value of, so we indicate the values of x sub 1, x sub 2, and x sub 3 here. Okay, so and x sub 2, that is 3, no? Okay, so we write f of 3 minus x sub 1 is 2. That is, we write also the f of 2 over the 3 minus 2, which is x sub 2 minus x sub 1, which is 3 and 2. Okay, so substitute 3 squared minus 2 squared over 3 minus 2. So, and the result is 5. Okay, so the gradient curve of EB is 5. So, 5. Next, gradient curve of BC. So, we change, no? F of x sub 3. So, f of x sub 3 here. Then minus of f of x sub 2. Okay? Over the x sub 3 minus x sub 2. So, equate. Substitute the value of 4. So, f of 4 minus f of 3 over 4 minus 3. Okay, so substitute the value sa equation, no? That is 4 squared minus 3 squared over 4 minus 3. The answer is 7. That is equivalent of 7. Okay, so therefore the curve of BC is 7 or equals to 7. So next, the gradient curve of EC. So where f of x sub 3 minus f of x sub 1 over x sub 3 minus x sub 1. Okay, so the value of x sub 3, that is 4. So f of 4 minus f, the value of x sub 1 is 2. So f of 2 over 4 minus 2. So the gradient curve of EC, which is 4 squared minus 2 squared over 4 minus 2. So therefore, the answer is 6. Okay, so the result is 6. The next, the differentiations from first principles. Okay, so now we also use this graph, no? I take coordinates, no, which is the point E, which is the we assume point E as x and y. Okay, so another point, that is point B, which is x plus delta x, and here is y. Okay, we have a y plus delta y. Okay, then that is the coordinate of point B, no? So here is from distance here, that is delta y. Okay, so then delta x. Then from here, that is f of x, and here to here is f of x plus delta x. Okay, diba in a previous graph, here is f of x sub 2. Okay, so where x sub 2, okay, which is y here, then y plus x sub 2 here. Okay, so that is equivalent of, okay, so that is also the equivalent here, no, from the distance f of x plus delta x. Okay, so again take note, this is we have a y here, y plus delta y. Okay, so therefore when we say a gradient curve of EB, so let us show, or let us show with this, no? So delta y is equals delta y over the delta x. Okay, so take note that where delta y is equals to f of x plus x. Okay, so in gradient curve, or gradient of the curve EB, is equivalent to delta y over delta x. So from the previous is line BC over line EC. Okay. Then take note that the delta y is equivalent to f of x plus delta x, then minus f of x. Okay, so minus here. So therefore we write this delta y over delta x is equals to f of x plus delta x minus f of x over delta x. Okay, so as delta x approaches 0, or delta y over delta x approaches a limiting value and the gradient of the curve, or curve approaches the gradient of the tangent at E. Okay, so next. So when determining the gradient of a tangent to a curve, there are two notations used. The gradient of the curve at E in the graph can either be written as, so like this, no? Okay, so the limit delta y over delta x, so where delta x approaches to 0. Okay, so or the limit delta x approaches to 0, or f of x plus delta x minus f of x over delta x. So that is the formula also, no? So in Leibniz notation, so dy over dx is equals to the limit of delta y over delta x. So delta x also approaches to 0. Okay, so in this notation, no? So next, functional notation. Okay, so f, or first derivative of f of x. Okay, so here this apostrophe indicate first derivative. Okay, or first derivative of x. So it is equals to the limit of f of x plus delta x minus f of x over delta x, where delta x is approaches to 0. So take note, this form is called a functional notation. Okay, with this, with this. Okay, so next. Okay, so dy over dx is the same as f of x and is called, take note class, dy over dx is the same as, okay, so we have here the apostrophe, no? Okay, so I forgot to write here, and it is called the differential coefficient or the derivative. Okay, so the process of finding the differential coefficient is called differentiation. Okay, so that is the differentiation. So differential coefficient, okay, so this is the formula. Okay, so dy over dx is equals to first derivative of x, f of x, then is equals to the limit of delta y over delta x, so where delta x approaches to 0, or equals to the limit of the f of x plus delta x, then minus f of x over delta x. So for example, so differentiate from first principle f of x is equals to x squared and determine the value of the gradient of the curve at x is equals to 2. Okay, so solution. So we use this formula, or which is the functional notation. First derivative of f of x is equals to the limit of f of x plus delta x minus f of x over delta x, where delta x is approaches to 0, and then we find f of x plus delta x by substituting this given, no? Okay, so we substitute the value of x here is x plus delta x. So we write here x plus delta x, then squared. This is a square binomial or uh, binomial square binomial theorem. Sorry. Okay, so x times x, that is x squared, then x times delta x, that is x delta x, another is delta x times x, that is x delta x. So delta times delta, so multiplying by itself, that is delta x squared. Okay, so don't forget the process, or you can study also if you cannot understand, no, by multiplying square of binomial. So you may review your algebra. Okay. Okay. So next, simplify, where x squared plus 2x delta x plus delta x squared. Okay, so in this term here is can be added. Okay, so we write here x squared plus 2x delta x plus delta x squared minus x squared. Okay, so we all know that x squared here on the numerator can be cancelled out because of this, no, minus x squared. So we write, okay, so the limit of 2x delta x plus delta x squared over delta x. Okay, so where delta x is approaches to 0 man. Then we cancelled out both terms with delta x, no. Okay, so therefore the remaining is 2x plus delta x. So where delta x is approaches to 0, so delta x here is 0. Okay, so here 2x plus 0, so therefore first derivative of f of x is equals to 2x. Okay, so again we find also the value of the gradient of the curve, and then we have the value of x. So substitute the value of x here. That is 2 minus 2 times 2, that is equivalent to 4. Okay, so therefore the answer is first derivative of f of x is equivalent to 4. So or the gradient curve, or the gradient of the curve is equivalent to 4. So that is the final answer.